The job market is already incredibly hard to break into, and even if you manage to land a job, keeping it is no guarantee. As a young graduate, I'm worried. Recent advances in AI have only made the landscape more uncertain. While the promise of technology is often about progress, what we're seeing is something different. Powerful CEOs like Jeff Bezos are using these advancements not to uplift workers, but to surveil them. In some warehouses, employees are tracked every second of their shift, even down to the length of their toilet breaks. I've worked in a warehouse for 3 years. It used to comfort me to know that, even if my degree didn't land me a job, I could fall back on that kind of work. But now, even jobs that used to feel stable and easy to fall back on are being taken over by machines, tightly monitored and made more stressful, making it hard to feel secure about the future or even comfortable doing them today. Our project, Could You Be an Amazon Worker?, is a satirical and dystopian reflection of the current world young graduates find themselves in. We started by asking ourselves, what will it be like to apply for jobs in the future? Today, we're already competing against AI, and job interviews, especially those in tech, often feel more like tests designed for machines. We thought about Captchas, which are used to prove that you are a human, and joked about that in the future you might have to prove that you're a robot or as good as a robot just to get a job. That led us to our concept, an interview to become an Amazon warehouse worker, designed as a satirical escape room. In this interview, they would be tracked on how fast they are, but also how careful they are with the packages. Now, let me walk you through how our project works. The interaction begins the moment the user picks up a box. They walk toward a white lit zone and place the box there. Once the box is correctly placed, the lights in that section turn green, signaling success. After 3 seconds, the light changes to blue, indicating that the box is ready to be relocated. At this point, the arrow on the robot dashboard increments. The user must then bring the box back to the starting table and repeat the process. If the user moves incorrectly at any point, for example, going to the wrong area, shaking the box, or removing the box too early, all lights flash red and the dashboard arrow decrements. If the user completes the task correctly within 3 minutes, they are rewarded with a 4-digit PIN code, which they can enter at the gate to finish the challenge. From there, they can type in their name and view their position on the leaderboard. The game ends automatically after 3 minutes. Before we got to this project, we had several prototypes that I will talk about now. First, we had to figure out what our warehouse shelf would look like. Initially, we planned to build our own, but quickly realized it was easier and faster to find one on Marketplace. This was the first shelf we found. It was great for prototyping, but too small and unstable for the final installation, so we upgraded to a larger and sturdier version. Since our sub-theme was data visualization, we also had to find a way to represent the user's performance in a visual and meaningful way. One of our early ideas was a tug-of-war indicator, a kind of physical dashboard that moved based on button inputs to show how robotic or human you were acting. To create a stressful environment, similar to those reported by real warehouse workers, we added flashing red lights and an alarming sound when mistakes were made. We also needed boxes to simulate the warehouse task. Our first version was 3D printed, but we later switched to a cardboard. For guiding the user, we wanted lights that would indicate where to place the boxes. Here's Will Harvey, after successfully wiring a circuit to make the lights respond to the accelerometer input. However, we ran into problems. The light sensors weren't sensitive enough, so we switched to buttons as a temporary solution, but they actually worked so well that we stuck with them. Later, we changed the tug-of-war idea to a robot with a dashboard to better reflect our message and make the data more readable, but the dashboard came with its own challenges. Maria and I spent several hours debugging, trying to figure out if it was a hardware or a software issue. Eventually, we discovered that some wires on the breadboard were too close, which caused signal interference with the servos. Even after fixing that, glitching persisted throughout the project. We learned that we should upgrade to better quality servos, which we did right before the project was due. Once everything else was working, we wanted brighter, more visible lights and found that LED strips was the best solution. I did most of the soldering for the project, and here you can see me soldering. With all of that in place, we could finally begin testing. If I could do this project all over again, I would upgrade to better servos as soon as we realized that they were causing problems. I would also wire up all 4 accelerometers right from the start, instead of just testing with one until the final week. That would have helped us catch key issues earlier and given us more time to relax, refine and properly test our prototype. However, I am super pleased with where we got and feel proud of what we created. We collaborated great together, and I would love to do similar things like this in the future. Thank you for watching. This was Tuva from the Captcha Chameleons.